already finished assembling all the wooden pieces of the bumper, and we are almost done attaching the pull needles that make up the outside of the bumper. And so once we finish attaching these, we have this purple fabric that we're going to cover the bumpers with, and these will be our show or parade bumpers that we'll use at demos later.
Alright, so we are testing a new design for our shooter. This is our 3-wide shooter. It's going to be able to shoot 3 balls at once. So right now this is the prototype. We're testing this out. And Jose?
Yeah. So the plan is that the balls will be coming in from our giant tank and they'll feed upwards. We don't have all the belts right now, but we're 3D printing more pulleys. And once they get to the top, we're going to have 2 rollers up here to spin, and hopefully that will shoot well.
Alright, it's January 20th, the second Friday of build season, and we're currently on our way to visit Solarcraft. They're one of our sponsors. They volunteer a lot of their time on their laser cutter and CNC brake. So we're actually going to pick up our first versions of our prototype drivetrain and collector.
So we got all our sheet metal parts today on Friday, so we have the entire weekend to build them up and hopefully get testing by the end of the week.
So this is our intake basically. We have 2 parts of it. First we have the mechanism intake, and then we also have the inner intake that will bring the balls to the elevator and the shooter. So basically right now we have just a bunch of mechanism wheels and compression wheels in the front. So they can suck in the balls and they go inside the robot. And all of this is just the one stage. We're gonna go make it in sheet metal, but right now it's... So previously we had the problem where our spacers would roll along with the ball, and that didn't have a lot of traction with it, so we added some surgical tubing to see if that would work. And we figured out that the flanges of the pulleys touch the ball before they actually touch the surgical tubing. And we just randomly saw some gum rubber tubing, and we were like, why don't we try that? And they seem to fit perfectly well, and this is how they work. And it basically works pretty fine.
So like, subscribe, and follow the vlog at Spectrum Favorites. Am I doing it right?
Alright everybody, remember, like, subscribe, and follow, all that fun stuff. Let's welcome to the show Spectrum. Gentlemen, why don't you, you've been on the show a couple times before, why don't you introduce yourself for anybody who's watching you today?
All right. I'm Alan Gregory. I'm the head coach for Spectrum.
And I'm Will. I'm a senior on the team.
Very cool. Well, welcome to Check-In. Again, a wonderful video. Showed all sorts of great stuff your team's doing. So let's dive right into it. So why don't you give us a rundown on what this week has looked like? Normally this is, like I said before, we're transitioning from prototype into beginning to design and make parts. So tell us a little bit about what you guys have been up to.
Yeah, that's pretty much where we're at. We did our prototypes a little bit more detailed than we've had in previous years. You already saw we did a lot of routed stuff. We actually have some sheet metal prototypes we're going to show off in just a second. So that we know that all the little details that we end up hurting us later, we're trying to get those knocked out early. And some of the bigger things that a lot of people are worried about, we're actually going to be tuning a little bit later. So like a lot of our shooter tuning, we know that we got enough compression on the ball now. We know that we are able to shoot it high enough. We'll get the angle and make sure that we can get it all tuned on the real one or on the next realer version of it that we're not necessarily doing this week.
Mm-hmm. Yeah, so over last week I was doing a lot of shooter testing, just getting our prototype finally built actually after we got all the routed parts done. Setting up all the spacers. We got in a couple more shipments from Vex Pro, so just putting in all the belts and all the pulleys so that we can get some testing done. And I think I was talking about we were working on some compression. And if you read our blog, you already know that we were a little wide, so we added some 118 calls it magic tape, which is some adhesive tape that we wrapped around it to get the right compression, so we can have it updated for the next sheet metal run, which is actually going out on next Monday, I believe. Yeah.
Oh, very cool. Wow, you guys have been very busy, it sounds like. So let's right into the meat of this. So you guys mentioned that you're going deep into the prototyping this year, and last year we talked a lot about your last week we talked about your router, and we actually saw some of it at the beginning of the show. Why don't you tell us a little bit about how you've been using that so far?
Yeah. So it's been a lot of just getting like a lot of arm geometry. So we have our gear intake that we've talked about a little bit. And we've been using the router to test out different ways that we can stand that off from our main robot and actuate it, and even the actual geometry for the box that is going to be the gear collector, just putting it together with some angle aluminum and wood screws. and then more recently, I've used it a lot for the shooter. And then we've used it for the collector as well, but now we have the sheet metal in-house. We've got it all put together. So we've already graduated from the plywood to the sheet metal on that stage and on the drivetrain.
Very cool. So you mentioned that you have multiple sheet metal runs going on.
Mm-hmm.
Is this the final sheet metal iteration of this system, or are you going to do it again?
Yeah, absolutely. So this so this is the very first run. We normally do 2, and sometimes they're later in the season. So this time we bumped one of those runs up earlier so that we can figure out how things get constructed and how we really don't like them. So actually, we're going to take our camera off of us briefly so we can actually show you the sheet.
Oh, no.
I know, we're moving. There's a robot.
Everybody.
So that's basically, a lot of people would be really pleased with that at the end of the season, right? It looks like a pretty decent robot.
Yeah,
we actually did all the wiring on it. So we're getting, a lot of it is training. So we have a lot of people who have hands who aren't necessarily doing the designing, right? So that we have something for them to do. And it helps a lot. So they're going to be able to wire the real robot really well because they've wired this one already. The real robot will be the 3rd robot we wire this 6 weeks.
Wow.
That intake on there is, we found that it's a bear to maintain. We built it and it works, but actually like doing anything to it is awful. So we have now we're redoing, the spacing is all staying, so we learned a lot from where that is, and we're changing that a little bit and changing the gaps and things. But we also are completely changing how it's built. So instead of having tube axle and hex bearings, it's now going to be using the West Coast Products roller system where they're using shoulder bolts into 3/8 bearings, which is a lot easier to put together and on and off because the entire roller will just be able to move on and off by itself.
See, that's something you'd never be able to find from like when you build one robot at a time, because you're building your robot before you even build your robot, basically.
Right. Yep. That's the point. Trying to get as much of the little things out so that for the next 3 months that we have to deal with this, we like dealing with the robot, and we don't keep hating the subsystems that we design.
I know with the shooter, I think we disassembled the shooter probably about once a day last week. And by the end of it, we're like, yeah, no, there needs to be an easier way for us to put this back together every time we need to take it apart.
Wow, that's an amazing story. So let's dive into this a little more, because in order to be able to build a robot 2 or 3 times, your design cycles have to be very quick. You got to be on top of this. So what are you guys using to come up with these sheet metal patterns or what have you? And who's doing it, and how do you guys break that up? And how do you, because like you mentioned, not everybody designs, but how do you figure that out exactly?
So a lot of the sheet metal, like I know when I did my sheet metal panel for the shooter, I just took the same sketch. I copied the part that was my plywood piece, and I just deleted the extrusion. I used the same sketch, and I made it just a sheet metal base flange. So it's the exact same sketch I was using for my plywood version, and I made a couple of geometry changes, like I changed the shooter compression, I changed a little bit of the angles, like how the ball enters the tower, but really it's the same sketch. So I'd already done all the legwork for myself when I was making these plywood prototypes. All I had to do was rework it a little bit for the final iteration and make it an actual sheet metal part instead of just an extrusion.
And so,
go ahead. No, you go on.
And the way we're dividing it up a little bit is we have about 7 students, I think, and myself who work on the CAD right now. And there's a few people who are they do little CAD pieces that aren't necessarily like a whole subsystem. There's about 7 people doing basically running subsystems. And so from there, they all do their work, and then they check up to me, and I'm the one kind of making sure things are going to fit together most of the time, and going back down and saying, no, this needs to change. We're not. How are we going to build this, or how is this going to be maintained? That kind of stuff, and giving those notes back. And then they're bringing in all the stuff from the plywood prototypes as the rest of the team is basically working on the plywood prototypes, maintaining them, figuring out what we're changing. We change up the line into the CAD and then into the sheet metal version. We basically use the same sketches that we do for the router on the sheet metal version.
Wow, so you've got basically a whole pretty complex workflow going here, where you've got people designing stuff, people testing that, sending feedback, and remaking those parts from wood to sheet metal, and sheet metal to your next round of sheet metal. That seems pretty. Is that true? That seems pretty complicated.
It seems more complicated when you say it, because there's a lot of us just like walking to the other room and talking to people. Then there's no like actual systems in place. It's really just like, okay, now it works. Okay, now I can see it. And then, oh, this needs to change. Then we build it into the next version.
Yes, nobody's walking around with an ECO checking things off.
Way too much of it is in like 3 or 4 of our heads, and we're just dealing with stuff half the time. One of the things we did this year that changed and has made the design process a lot easier is what we call the master sheet. So we have a Google Excel sheet that we borrowed some information from, I think it was on Chief. I'll probably publish a copy of it tonight in our blog. But that thing has been invaluable. So it has all of our belt calculators, all of our drivetrain calculators, all of our standard spec stuff. So like what hole do we drill for a certain rivet, or what on the laser it might be different for the router, just because the tolerances are a little bit different. So all of those specs are there. So everybody's designing off the same information, and that makes it a lot easier for us.
That's wicked good. That's a very smart idea. Before we go and talk about how your prototypes are doing, now that we know how you do it, let's talk about your prototypes. But let's take a look at a question from the chat. The chat sent it in. Again, if you have a question for us, just type !Q in the Twitch chat, followed by your question, and we'll answer it if we like it. So Hannah F7 asks, are you guys building an additional practice robot in addition to the practice robot you literally just showed us? Or how many robots are you going to build in this 1 week, in the 6 weeks?
So this isn't actually a practice robot. This is still it's prototype V2. So
this is like, the other one was like alpha, this is like beta, and then we'll get 2 roughly identical robots that we'll be able to practice with and compete with.
I see. So you'll see a lot of teams, their beta will be the practice robot, but in reality you have a true beta, and then you're building 2 production units, basically.
Yes.
And this will get gutted for some spare parts. A lot of electrical will probably move off this at some point. Like, this will probably not run forever.
Right.
We
like
may
most
keep
betas.
Programming, things like that. We'll figure out when it dies, but it will not be around at some point in the competition season.
Cool. All right, so let's talk about all that stuff. So what are your results from prototypes? What have you guys figured out? We saw some more about that shooter that we talked a little bit about last week. Give us the details on that.
So the most recent revision of the shooter, the shot was a little off. We think most of that was due to the compression on the one we had on like sliding bits of aluminum, some rev. Mm-hmm. The compression on that being a little bit more than what we'd actually measured and reported. So when we went to make the most recent plywood one, it came out a little big. So like I said, we added some magic tape, increased the compression a little bit, and remeasured that compression. So when we make the next sheet metal run, it should be a little bit more accurate. And then, so we know we can get enough power out of our shooter. That's not the question. That's not the problem. So the next step is looking at redirecting the ball and making sure we actually get a straight shot, an accurate shot, a consistent shot. So we've already been through one revision of our Macker, which is basically it's a 3D printed hood. It's sitting on my desk right now, so I don't have it to show you. Because it broke, because we made it out of 5% fill PLA. So
for those who don't speak 3D printing, that's kind of flimsy, right? Basically, is what you made it.
Yeah.
Okay.
So that broke after, it started splintering after about like a dozen shots, and then I accidentally tried to pick up the shooter by it, so it actually broke. But I redid the geometry, so it's going to be a little sturdier. It was originally just it's like basically L-shaped, and I had a little fillet in the back holding it together, but now it's like properly triangular, so it should hold together a little bit more, and we might use a little bit more than 5% fill.
So the rest of the shooter, basically, we know that we have 4 775 Pros on timing belts 1 to 2 to about 1.5 inch rollers.
Okay.
For that. So, and it's able to launch the ball quite far. We're almost like lifting the ceiling tiles. So we see them shake when we're hitting it in our lab.
Nice.
So we know we have enough power, and we'll be able to tune that down to get to the amount that we need. And then we'll be able to adjust angle and stuff as we're getting the rest of it. Right now, a lot of what we're trying to make sure we do is we're able to feed it fast enough. So we're working on getting the belts efficient, that we can be able to feed it up. I think in the last episode, we talked about how we're going to basically have them in rows. So instead of what you saw earlier in the video where 319 is just kind of sending balls through, which definitely works, we're going to have it a little bit more organized, so that we're almost able to aim our 2 outside ones too if we need to. We could change those angles independently of the center. So if we need to aim them, we're not sure yet, but maybe. We can do a little bit of more adjustments on the top end to each individual 3 rows of balls that'll be coming up.
And part of our goal also with that is we realize that if we are shooting 3 wide, that's going to be a lot harder to get dead on than just one ball where you've got the full 20 inches of play. Yep. With a 15-inch stream, you have 5 inches of play. So if we're a little bit off and one of our streams isn't quite hitting, our plan is to have some servos mounted inside of our tower that we can use to cut off each individual stream.
Oh, okay.
So that if we know we're a little bit too far to the left, instead of like just throwing away that third of our hopper, we can cut off one of our shooter lanes and keep the other 2 going, and maybe we lose like 5 or 7 balls that are still caught in the hopper or caught in that lane, but we're not just throwing them away onto the side of the boiler.
Very cool. So I kind of want to touch before we end tonight on a couple of things. Have you done any significant work on a climber or on gears yet, or are you mostly focused on getting the drivetrain beta and your shooter together?
So climber, we haven't done. We did it well, early on. We realized that we have motors. Doing it on the motors is easy. We can get the lift to do a winch relatively quickly. We're actually waiting on a West Coast order for some more of the 1.25" tube.
Okay.
That didn't get shipped out, but when that gets shipped out, we should have a prototype climber built up and mounted on that robot, so we can start playing more with the rope geometry. Because we want to make sure that we actually have it driving into it and testing it. The plan is to use some form of Velcro and either a rope that's really Velcro-like or sew Velcro into a rope. On the gear intake, we've been playing a lot. Our plan right now is to have a top roller, like I think we've seen in at least one of our videos. And we just ordered some carbon fiber to go across the bottom to give it a nice bottom edge. So it's 30-second thick carbon fiber sheet. So then it's able to slip up onto that very easily. And it's relatively stiff and strong. And we're pretty sure we've tested enough. I've literally just been beating it across tables to try to make sure it's not going to break.
Yep.
We're not 100% sure yet, but we hope.
Is the reason you chose carbon fiber over like a thin plastic or HDPE?
Yeah, so we've tested 30-second HDPE, but it starts to wrinkle a little bit. So they were trying to find something that's not going to have any defects in it when the gear comes out, because it'll just stop it from sucking in. So we ran through HDPE, Lexan, Garolite. I think that was it before we went to carbon fiber. Stuff. It's relatively cheap.
Yeah, it's good to do your due diligence, especially with stuff that can be kind of expensive like that. So
yeah, we found a place that'll sell us blemished carbon fiber because we don't actually care what it looks.
Right, exactly.
Got it pretty cheap.
Nice. Is it purple though?
No, it's black.
All right, well, we'll take it. Speaking of all black, up next on check-in, we've got Team 148. They're from Greenville, just a few hundred miles away from you guys. Spectrum, awesome. Thank you so much for sharing this all with us. You guys are doing something pretty wild, building all these different robots in 6 weeks, and I can't wait to see how it turns out in the end. So thank you guys so much, and we're going to be right back with our next team. So thank you guys.
Thank you.